Hello guys, welcome back to the channel. In today's video, we will build a server, or in other words, a complete REST API. And this will be achieved using Typescript, NodeJS, and MongoDB. In today's video, we will build a service for managing books. This service will include the following: a built-in authentication with username and password, CRUD operations for books which we will store in our database, and as such, we will cover the following talking points. We are going to look at the project setup. We are going to install the dependencies for our project. We are going to create a basic Express server. Then we are going to set up our authentication service, which includes creating accounts and logging in a user. We will set up a book model and service, which will allow us to run CRUD operations on our book. So if you think that's a great idea, please leave this video a like so others can find it. Make sure you subscribe to the channel so you can see all of our videos in the future as they drop. Let's start with the project setup. Let's open up a browser tab and navigate to the home page for TypeORM. This is because we will use TypeORM as our ORM for the server we will be building. If you don't know what TypeORM is or how to use it, then I'm going to suggest that you visit our previous video on getting started with TypeORM and MongoDB, just so you have a clear understanding of what TypeORM is and how to use it with MongoDB. We'll scroll down the page till we see the section where we see a command for quickly spinning up a TypeORM project. Let's copy this command first, then we open up a terminal. Let me quickly navigate to our project directory. I'll paste in that command we copied from TypeORM into our terminal. Then we'll modify the database to be MongoDB and change the project name to be Bcrypt. Then we are going to go ahead and hit enter. We'll wait for TypeORM to install and set up the project. Then we navigate to the project directory, open up the project in VS Code. Let's navigate to the src/entity/user.ts file. And you can see that we already have a user entity created for us by default when TypeORM was setting up our project. This entity already has some properties defined on it. However, don't worry too much about it because we are going to change most, if not all, of these properties shortly. I'm going to go ahead and delete the migration folder because that is beyond the scope of our topic for today's video. Now, let's open up the datasource.ts file. It is inside of this file we define our database connection. Inside the object we pass to the data source constructor, we delete the migrations and subscribers property because we don't need them either. Now, let's go ahead and install Express so we can set up a basic Express server. We'll open up our terminal and type npm install express course and hit enter. We wait for those dependencies to finish installing, after which we will install the type definition for Express and for course. Then we'll open up the index.txt file. We'll import Express from Express. We'll create a variable app which stores the results of calling the Express variable we imported from Express. Then we'll call app.listen on port 3000 and log out a message to the console which reads app is running on port 3000. Then we'll create a .env file. And inside that, we'll create a database_URL variable, which we are going to go ahead and copy and paste the link to our MongoDB instance as the value for this variable. Then we'll create another env variable, database_name, which is equal to Bcrypt. Open up the datasource.ts file. Then we'll install .env. We will import .env and call .env.config. Then we set up the database property on our data source object to be equal to process.env.database_URL. When you add a new property to the data source constructor URL, which is equal to process.env.database URL, let's navigate to the index.txt file. Then we import the app data source from datasource.txt file. We change a call to app data source to initialize, and this is a promise, and as such we change a call to the .dem function and pass in an arrow function as the argument to it. Let's expand the arrow function, and inside of it we'll console log a message informing our user that they are successfully connected to the database, after which we listen and serve our app on port 3000. We are also going to change a call to the catch function to handle any errors that arises from creating and running our server. We'll open up our package.json file and add a new script dev to the script section of our package.json file. This dev script uses nodemon to run our application. We'll open up our terminal and run npm install nodemon to install nodemon. Then we will type npm run dev from our terminal and hit enter. And you can see that our app has successfully connected to the database and is now running on port 3000. Let's head back to our project on VS Code. We open up the src/entity/user.ts file. We'll change the ID property to _ID. Then we'll delete all other properties defined on this user class. We add a full name property, which is a string, add a username property, which is also a string, add another property, password, which is a string, and finally a role property, which is of a narrow type, admin or user. We'll create a new folder, which is inside of the src folder. We name the folder services. We are going to create a new file, auth.ts, inside of this services folder. Inside this file, we import the user entity which we just created. We will create and export a class user service from this file. We will define a method on this class create. This method accepts an object as its argument. The object has a username property and a full name property, and also a password property, all of which are of type string. Then finally, we are also going to accept a role property. Let's open up our terminal to terminate this our server that we are currently running, and then we are going to proceed to installing Bcrypt. This is a package that allows us to encrypt our user's password, and after that is done, we are also going to install JSON Web Token. When we are done installing JSON Web Token, we'll install the type definition for JSON Web Token and Bcrypt. Now, back inside the auth.cs file, inside the create function, we will create a variable user, which is equal to the result of calling app.dataSource.create. We'll pass in the user entity as the first argument to this function, and then we'll pass in the username, the full name. Let's create a new file, helper.cs, inside the src folder, and inside of this file, we will create and export a variable hash password, which is a function. This function accepts a string password as its argument. First, we import Bcrypt inside this file, and inside of the hash password function, we will return a call to bcrypt.hash. We are going to pass in the password argument as the first argument to this function, and then we will pass in 16 as the sort round for encrypting the password. We go back to the auth.cs file, then we import the hash password function we just created. We set up the password variable to be equal to the return value from calling the hash password, and then we pass in the password property we accepted as an argument to the hash password function. Finally, we pass in the role property, and then we navigate back to the helper file where we will create and export a new variable create token. This is a function that accepts an object with a username and an ID property, both of which are strings. Then we are going to import JWT from JSON Web Token. Inside of this function, we will create a new variable token, which is equal to calling JWT.sign. We will call JSON.stringify and pass in the object argument to the function. Our secret for encrypting this token is test1234, and then we are going to pass in an object as the third argument to the JWT.sign function. We set the expires in property, which determines how long our token lasts, and then we are going to return this token from this function. We'll navigate back to the auth.ts file inside of the create function, and we will create a variable token which is equal to the result of calling the create token function, which we import from the helper.cs file. We are going to pass in the username of the user and the ID of the user as the argument to this create token function. Then we are going to return an object from this function. This object has the user and the token as properties on it. We will create a new function save, which allows us to save a user. Then we will wrap the add.dataSource.create function with a call to await this.save to ensure that all newly created users are saved to the database. Let's create a new file inside the src folder, router/index.ts file, and inside of this file we will create and export the variable auth_routes, which will be equal to an object. Inside this object we have a create property, which is equal to /create. We have a user property, which is equal to /user/semicolon token. Finally, the object we have another property login, which is equal to /login. Then we will create another file inside the router file. This file will be named auth.ts. Inside of this file, we will import the router function from Express. Next, we will also import the route objects from index.ts. We will create a variable router, which is equal to the result of calling the router function we import. We will change a call to router.post to add a post method to our server. The route for this post method is going to be the auth_routes.create. Let's create a new folder, controllers, inside the src folder. Inside the controllers folder, we create a new file, auth.ts. We import the user service from services/auth. Then we will create a new variable, user service, which is equal to the result of instantiating the user service class. We will create and export a new function, create account. This function accepts a request argument, which is of type request, and a response argument, which is of type response, both of which we import from Express. Inside the create account function, we will create a new variable body, which is equal to the request body. Then we add a try catch block. Inside the catch block, we will set the status of the response to be 400. Then we send back the error message to the client. Inside the try block, we will create a new variable payload, which is equal to the result of calling the user service.create method. Let's pass in the body variable as an argument to the user service.create method. Then we set the status of the response to be 400 and send the payload to the client. We'll go back to the router/auth.ts file and import the create account function from controllers/auth and pass it in as a handler function to the router.post method. So anytime we make a post request to /create, the create account function will be called. Then we will export the router object as default from this file. let's navigate to the index.cs file inside the src folder where we will import course from course. Then we will call app.useCourse, and this allows us to make requests to the server from our app or any other app. Then we are going to add an app.useExpress.json in order for us to pass the request body of type JSON. We will import the auth router from router/auth.ts and call app.useAuthRouter to register this router onto our app. Let's open up a terminal and hit npm run dev to spin up a local server. Once that is up and running, we will create a .http file in the root level for our project. This file will be used to test the API endpoint for our application. Let's go ahead and test the create endpoint. We set the full name of the user to be John Doe. The role is going to be your user. Username is going to be John Doe, and the password is going to be test1234. Then we are going to go ahead and send this request. You can see the newly created user in the console, and you can also see their token inside of the response. Now let's add the login function. We'll navigate back to services/auth.cs and add a new method to the user service class named login. This is an async function that will accept an object with a username property and a password property. Inside this method, we will get the user via the username by calling app.datasource.mongomanager.findOneUser, where the username is equal to this username argument that we are accepting here. If the user does not exist, then we throw an error, incorrect user. However, if the user exists, compare the password passed into the login function to the user's password. But first, we will navigate to the helper file where we will create and export a new function, verify password, which accepts a string password as its argument. Inside this function, we will return a call to bcrypt.compare, and we pass in the first password argument. Then we accept another argument, the existing password, which is also a string. We will pass this as a second argument to bcrypt.compare. This compares the password of the user, that's the one they want to use to log in, and their existing password. We'll go back to the user service class, specifically the login method. Then we will import and call verify password, call the verify password function from the helper file. This returns a boolean, and if it's true, we will return an object with the user property and a token property, which is equal to the result of calling the create token function. If the passwords do not match, we will throw an error, incorrect password. Now let's navigate to controllers/auth.ts where we define and export another root handler function named login, and this allows us to log in an existing user. After which we will also define and export another root handler function named getUsers, which allows us to fetch all the users we have created. We navigate to services/auth.ts and add a new method to the user service class, getExistingUsers. Inside this function, we will return a call to app.datasource.mongomanager.findUser, where the role is equal to the role that we passed in. Then we accept the row argument on the method, which is of a narrow type, admin or user. We head back to controllers/auth.ts and complete the getUsers handler function by extracting a row variable from the request params. And of course, we are going to strongly type the request object because why not? Then we head back to the router/index.ts file and define a new property on the route objects, which is equal to /user/semicolon row. We'll open up the router/auth.cs file and register a post request for logging in the user with the auth route.login. Then we are going to pass in the login function as the root handler function to this auth route.login, and we are going to import this login function from controllers/auth. We will also add a get root handler function for retrieving all the users using the auth routes.users route, and the get users route handler function will be passed as a root handler function for the auth routes.users route, and we are going to import this get users route handler function from controllers/auth.cs. Now let's open up our .http file so we can test these routes out, starting with the login route. We see the payload which contains a user object and the token for that user. Then we are going to test out the getUsers method to retrieve all the users whose role is user. I can see that on the payload we get an array 2 users. Okay, now let's head back to the services/auth.cs file and add a new method, getUser from token, which accepts a token argument which is of type string. We will navigate back to the helper file where we define a new function, verify token, which accepts an argument token, which is a string. Inside this function, we'll return equal to jwt.decode. We are going to pass in that token as an argument to the jwt.decode function. Then we'll navigate back to services/auth.cs file, specifically the getUser from token function, where we will destructure out the ID variable from the result of calling the verify token function. which we will import from the helper file. We use the ID to find an existing user and return that user from the function. However, if there is no user, then we are going to throw an error, invalid token. Now we'll head back to the controllers/auth.ts file where we'll copy and paste the getUser function. We will change the name of the function to getUser. Then we'll change the type of the request param from row token, which will also be a string. We'll change the row variable with the structure from the request param to token. Then we'll change the function call from getExistingUsers rule to getUser from token. Let's navigate to router/auth.ts file where we register a new GET request to authroute.user, which is essentially /user/token. Then we import and pass the getUser function from the controllers/auth.ts file as the route handler function for the authroute.user route. Okay, now let's go ahead and test the get method we just added, but we need to retrieve a token first. So that is, we need to log into our account first. Then we use the token returned to us to fetch the user, which you can see in the result tab. Now we are done with the authentication part of our application. We'll start implementing the CRUD features for our app. We will create a new entity inside the entity folder named book. Inside this file, we import a bunch of decorators from type ORM. We will import the entity decorator, the object ID column, and the column from type ORM. We use the entity decorator to decorate a class, which we will export from this file. Next, we will decorate an underscore ID property with the object ID column, which is of type object ID. We add a title property, which is a string, a thumbnail property, which is also a string, a PDF URL property, which is a string, a pages property, which is a number, an ISBN property, which is a string, a publish property, which is a number, and finally an author property, which is a string. Let's head back to the entity/user.ts file where we'll define a books property on the user. Now we'll create a new file inside the services folder. The name of this file will be book.ts, and inside of this file we will create and export a new class, book service. We will define a new method create on this book service. This method will allow us to create a new book. This method will accept an argument with a title property, author property, ISBN property, a publish property, and a pages property. Inside this function, we'll return a call to app_datasource.create book. We will add a save method on the book service. Then we will wrap the return statement from the create method with a call to the save method. We will create a new file inside the controllers folder named book.ts, and inside this file we will create and export a new variable, create book, and it will be equal to the route handler function where we will create a new variable which is equal to the request body. We will create a new book variable which is equal to the result of creating a book, which we will send back with a response. Now we will navigate to the index file in the router folder. Let's define and export a new variable called bookroute. Then we'll add a new property create on this object whose value is /create-book. We will create a new file inside the router folder named book.ts, and inside this file we'll import the create book function from controllers/book. Next, we will create a new router object which is equal to the result of calling the router function. Then we will add a post method on the router object. The route for the request will be the bookroute.create, and we'll pass in the create book function as the value for this route handler function. Then we will export this router as default from this file. We head to the root index file where we will import the book router from router/book. Then we will register the router onto our app. We'll open up the .http file where we will test this create book route. We'll ensure we pass the correct payload as the request body. Then we'll go ahead and test this method, and you can see that we get an error, metadata not found. This is because we did not register our book entity onto our app data source, which we will do by importing the book entity into the data source.ts file. Then we'll add it to the entities array. We'll go back and test the book method again, and this time you can see the book in the results tab. Now let's head back to the book service. This time we'll add two new methods to the book service, starting with a method named getBookById, which accepts an ID argument which is a string, and inside this function we use the ID to find a book whose property is equals to the ID argument. Then we'll add another method, getBooks, which returns all the books we have created. We'll navigate to the controllers/book.ts file where we'll add a new route handler function named getBook. We'll strongly type the request params to be an object with an ID property, which is a string, which we will use to retrieve a book from the books collection using the new book service.getBookById. method. Then we'll send the book along with the response. We'll also add another root handler function named getBooks, and inside this function we'll create a variable books which stores the result of calling the new book service.getBooks method. Then we'll send the books back with the response. We'll head to the router /index file and add 2 new properties to the book routes object. A book property which is equal to /books/id and a books property which is equal to /books. Let's go ahead and open up the router /book.ts file where we register a new get request to bookroutes.book. Why? The handler for this route will be the getBook function, which we will import from controllers /book. Then we register another request to bookroutes.books. Why? The root handler function for this will be the getBooks function, which we will import from controllers /books. We'll go ahead into our .htcp file, test this method out, starting with trying to fetch all books we have created. Then we use the _id property of one of the books we retrieved to try and get a single book, which you can see in the results tab. Okay, we'll head back to the controllers /book.ts file where we'll create and export a new root handler function named soft_delete. Inside this function, we'll type the request body to an object with a book property which is of type book. Then the request param will be an object with an id property which is a string. We'll create a new variable existing book which is equal to the result of calling await new book service.getBook by id. We'll pass in the id variable which will be structured from the request param, and if there's an existing book, then we are going to update each property on the book object based on whether or not they exist on the book payload, which will be structured from the request body. Then we are going to go ahead and save the updated book, which will send along with the response back to the client. I'm going to rename this function to update book. Let's go ahead and define and export another root handler function named hard_delete_book, which allows us to delete a book. We can see that we already have an implementation for soft_delete_book right above the hard_delete_book, and you can guess from the name, soft_delete_book allows us to mark a book as deleted, while hard_delete_book allows us to actually delete that book from our database. Let's go back to the hard_delete function. So first, we'll strongly type the request param to be an object with an id property which is a string, and inside of this function we extract the id property from the request param. Then we'll create a book service variable which is equal to a new book service. We will try to use the id property to find a book if the book exists. Then we are going to call await book service.deleteBook. Then we'll send a message to the client that the book has been deleted successfully. Otherwise, if the book does not exist, then we'll set the status of the response to be 404 and inform the user that the book does not exist. We will open up the router /book.ts file where we register a patch request to bookroutes.book and then pass in the update book function. Next, we register a put request to bookroutes.book and pass in the soft_delete function as a root handler for it. Finally, we register a delete request to bookroutes.book and pass in the hard_delete_book function as the root handler for it. So let's go ahead and test these methods out by opening up the .htcp file where we will try to update a book. This works the way we want. Then we are going to go ahead and try to mark a book as deleted using the soft_delete method, which also works. We will try to fetch all the books we have created. As you can see in the result that there is a book that's been marked as is deleted. Next, we'll try to hard delete a book, and you can see the result on the result tab that there is a message with book deleted successfully. Now we'll create a new file inside the entity folder. We'll name this file comments.ts, and inside of this file we'll import some decorators from type rem, starting with entity, then column and object ID column. We'll import object ID from MongoDB. We'll use the entity decorator to decorate a class comment, which we will export from this file. And inside of this class, we'll use the object ID column to decorate an _ID property, which is of type object ID. Then we will add a contents property, an owner property, which is an object with a full name property, and an _ID property, both of which are strings. Then we'll define the book property, which is a string. We'll also define the status property, which is of a narrowed type. Let's create another file inside this entity folder. We name this file notes.ts. We'll copy the contents of the comments.ts file and paste them inside the notes.ts file and change the name of the class from comments to notes. We will create a new file inside the services folder and we'll name this file comment.ts. Then we import the comment into this file and create and export a class comment service. We define a create method on the comment service that will accept an object use of type comment as its sole argument. Then we will use this object to create a new comment. Next, we define a save method on the comment service that allows us to save and update a comment easily. We'll also define a delete method on the comment service. We will define a new method on the comment service named update comment, and this method will accept an ID argument which is a string and a status property which is of type comment status. We will pause with this function implementation and define a new method getComment by ID that will accept a comment underscore ID argument which is a string. Then we will use the comment underscore ID argument to find the comment whose underscore ID property matches a new object ID of that comment underscore ID argument. We will come back to the update comments method implementation where we try to retrieve a comment with the ID argument, and if that comment exists, then we'll update the status of the comment and save it to the database. We'll copy everything inside of this file, then we'll create a new file inside the services folder. We name this file notes.ts. We will paste the contents we copied from the comments.ts file into this note.ts file. Then we'll change the import statement from comments to note. We'll update all the method implementation to fix all errors that are in this file and head back to the entity/notes.ts file. We'll remove the status property from the note class because notes are personal and there is no need for a status property. Then we'll create a new file inside the controllers folder. We name this file comment.ts, and inside this file we'll import the comment service first. Then we'll create and export a new root handler function named createComment. We will strongly type the request body to be an object with a comment property, which will be the structure from the request body. We use this to create a new comment, which we will send back to the client with a status of 200 if everything goes according to plan. Otherwise, we'll send back a status of 400 if we encounter any error while trying to create a comment. We will create and export a function getComment. We'll copy the createComment function we just defined and paste in the contents. We will rename the function to getComment. We will ensure the request has a params with an ID property which is a string. Then we'll use that to retrieve a comment from the database and send it back to the client. We will create and export another root handler function named getBookComment. We will type the request params to be an object with the book underscore ID property which is a string. We will destructure the book underscore ID property from the request params. We will pause with this function implementation. Then we will head back to services/comment.ts where we will define and export a new method on the comment service named getBookComment. This function will accept an argument named book underscore ID, and this will be a string. We use the book underscore ID property to find all books whose book property is equal to the book underscore ID argument. We head back to the controllers/comment.ts file where we will continue with the getBookComment function implementation and replace the call to getComment by ID with the call to getBookComment. Then we define and export another function, updateBookComment. We'll update the request params type to be an object with the comment underscore ID property which is a string and a status property which is of type comment status. We destructure the comment ID from request params and the status property from the request body. Then we use the two arguments to update the status of the comment. We'll open up the services/comments.ts file where we update the getBookComment method. We attempt to fetch comments based on their status and we will first pause and head to the entity/comment.ts file where we import the created date column decorator from type ORM and use it to decorate a created property which represents when a book was created. And then we head back to the services/index.ts file. We update the getBookComment function by ordering the results by the created property. We will just add that to a comment. We will navigate to the router/index.ts file where we define and export a variable named comment route. This will be an object with a create property which is equal to /createComment. Then we will add another property which is a book underscore comment which is equal to /book-comment / semicolon book underscore ID / semicolon status /colon status property, not semicolon. We'll also add another property, update comment, which is equal to /comment /colon comment underscore ID. Then we'll create a new file named comments.ts, and inside of this file we'll import router from Express. Then we'll create a new router object and add a post request to comment routes.create. Then we'll register the create comment function as the handler for this post request. We'll also register a get request to comment routes.book comments. Then we'll register get book comments function as the root handler for this get request. We'll also register a post request to comment routes.update comment and register the update comment function as the route handler function for the request. We'll export the router as default from this file. Then we'll head back to the root index file where we'll import the comment router and register it onto the server. We will head to the .http file where we'll try to create a new comment, and you can see the newly created comment in the results tab. We'll attempt to get all the comments registered on a book, especially those that are pending. But first, let's update the status of a comment. We'll create a new comment first, then we'll use the underscore ID property of that created comment, update its status to be accepted. Then we'll try to fetch accepted comments, which we also get back in the result tab, and you can see that there's only one accepted comment. Then we will head back to the services /node.ts file, and let's add a new method to this class named get user book notes, which takes in a book underscore ID argument, which is a string. We use this book underscore ID argument to retrieve notes whose book property matches the book underscore ID argument. Then we will create a new file inside the controllers folder named notes.ts file. Inside this file, we'll import the note service, then create and export a root handler function named createNote. This is responsible for creating a note with values extracted from the request body. We will also define another root handler function named get user book routes, where we will extract the book underscore ID variable from the request params. Then we will head back to service /node.ts to update the get user book notes method. We'll add a second argument to the function named user underscore ID, which is a string. We use this user underscore ID argument to also ensure that we only retrieve notes that belong to a particular user with this user underscore ID argument. We will head back to the controllers /node.ts file, then finish up the get user book notes function by passing in the right arguments to the node service get user book notes. We'll open up the router /index file. We'll define and export a new object named node routes. We'll define two properties on this object, a create property and a get book notes property. Then we'll create a new file inside the folder named notes.ts, and inside this file we'll import the router function from Express. Then we'll create a router by calling the router function and storing the results inside a variable named router. We'll register a post request to noderoutes.create, and the route handler function for this route will be the createNote function, which we will import from controllers /node. We will also register a get request to noderoutes.getBookNotes, and we will set the root handler function for this part to be the get user book notes function. We will also import from the controllers /node, and we set the root handler function for this part to be the get user book notes function, which we will also import from controllers /nodes. Then we will export the router variable as default from this file. We'll head back to the root index.ts file where we import the note router from the route /nodes and register it onto our server. We head back to the .http file to try and add a note to a book, which we will do successfully. Now let's try to find the notes of a particular user, which we also do successfully. I'm going to let you figure out how to ensure that only logged in users are able to add comments and notes to books. And that's going to be it for this video, guys. I hope you found it useful and interesting. Please leave this video a like. Make sure you subscribe to the channel so you can get access to all of our videos in the future as they drop. And I'm going to see you in the next one.